perfect cube, or unless you can do a grouping. Otherwise, you can't factor it. So I gave you the root for this one because even though they're all rational numbers, you're not going to spot them in your table. So I figured, let me just give you one of these. If not, you can always do a calc zeros and find one that you can use. You can't use an irrational one, but you can use a fraction. And this would come out 0.66667. That's your 2/3. You can use any one of these. So start, pull out your coefficients. Make sure you count down 3, 2, 1, 0, and start dividing. This comes down, multiply, come across. Anybody have trouble with this? I'll gladly do it. What?
Divide by 3.
You didn't divide by.
I didn't divide by 3 to get this.
Oh, you forgot. You didn't have to. You didn't have to do that. You didn't have to divide by 3. You could divide by 3 if you wanted to reduce that. You can factor that. That's factorable. When you get down there, that's factorable, but just with large numbers. When you reduce it down, you should still get the same answer. It's factorable. I just took the factor of 3 out because it just made it easy to factor. But you can absolutely do 8 times 8. You can put it in, you can do the quadratic, you can complete the square. Whichever, this is not bad for complete the square either. You take out the 48, there's a 1, so that's not so bad. I just did it just to save on the big numbers. Once you get down here and you have a square, see, it might not always look pretty, but you have a bunch of ways to do it. Try factoring. Always try 8 times c to see if it's possible to factor. If then you can find your factors. If it is possible, you can always do the quadratic. You can do complete the square. Are we good with this? Anybody not? Okay. Was this one? So you had to find these yourself, right? Mm-hmm. Now, this has 4 roots. I have 4 roots. I can only factor something that's a square. So how many roots do I have to find in my calculator? 2. I have to find 2 roots. So I have to divide like the second one we did in class. So I have to divide twice synthetically. It doesn't matter what order it's in. When you pull this out, this is a 0. That's what goes here. When you do this, this is a factor. You set this equal to 0, and you find your zeros. So when you find it in your calculator, that is a 0. Use that to be your divisor. Bring it down. Don't do the x squared thing when you get here. Just take the next factor, root, and do it again. If you don't come out with a 0 here, something happened because it is a root. It has to have a remainder of 0. When you get to this part, you took away 2. So z to the 4th. You took 2 away. So you went z to the 3rd, z squared. This is a z squared, z. That's a z squared. Now, this one had imaginary numbers in it, and I apologize because I was a little bit ahead of myself on this. This one had the imaginary number in here. If you're here, you subtract 2. You could, if you said to me this had no real root, that's fine. So basically, it only had 2 real roots. It had -1 and 2. And when you graphed it, you saw that it only made some like wiggly thing, and it only crossed it twice.
When do you know you have to use 2 instead of 1?
Oh, from this. Whatever you start with, you have to get down to a square. So if this had 8, you'd have to get 6 of them to get down to a square. I won't give you that many. I think 5 is the highest we do. So that you do this 3 times. You have to get down to a square to factor because you have your quadratic, you have complete the square. Every once in a while, a cube comes out as a perfect cube, but it's not too often. This one, and that's what we're going to do today, when you take the square root, because you can't take it for a real root, we're going to take out the I today. And so this would be I radical 2, plus or minus. So technically you have 4 roots. 2 of them are imaginary, and I apologize for that. That was totally my fault yesterday. I went back and looked at all the things I handed. I put the same thing twice instead of lesson 4. Are we okay with this? Dividing down twice? Yeah. And anytime, stop me and we'll do it together. Because these do get a little confusing. What's in here? I think. God bless you. I like that. Let's see if I can get this to work. This just doesn't want to be cooperative today. Yesterday it was me, today it's my board. Totally have a wacky classroom. Did I give you this one?
No.
This one. The one up? This one? Okay. Okay, so now, the highest roots are 4. I have 4 roots in here. So for me to be able to factor, I have to find 2 of them in my calculator. If you find 3 of them, even better. Keep dividing all the way down so the last thing you get is the last factor. And that's fine. When you do this, you're going to find that 1 is a double root, and you can't tell that when you first see that in your table. So when you divide by 1, you bring it down here, and you're going to factor that, and one of them is going to have the same root. And this is another way to write your equation when you bring these backwards. And when we leave it in factored form. Yes? No? All of you were good with this.
Yeah, I did the quadratic formula and got the same thing.
Yeah, quadratic is good. Quadratic, complete the square. That's why we have to get down to a square. Quadratic is good. Always do it like this first. So 2 times 1 is 2. Do I have factors of 2 that add up to -3? That tells you if it's factorable. And since both of these are prime numbers, well, this is a prime, this only has 1 factor. It's not so bad to put it in there. They're both negatives. Can only go in one way. The quadratic, absolutely good. Was this the last one?
No, because
That's it?
I think I know. I just want to double check. So when you divide twice, like you have to take like I kept doing it wrong. Like for this one, I had 2x to the third instead of like you have to take away 2x's because you divided twice.
You got to here?
No, I did both the
Okay.
divided, but
So you have to drop it twice. If you take one away,
okay.
you're in x third to 2. If you take another away, you're in x squared.
I just kept messing up on that part.
Think of it like this. If I divide this thing by this factor, x minus 1, x plus 6. These would be my factors for these roots. So this gives me x squared or y squared. So y to the 4th over y squared gives me y squared. Just keep subtracting each one you do. Just take it off of the numbers. Okay. Does not want to cooperate. But, no?
we had x.
This one. Down? You had,
Oh, that's right. Well, we had that, but
we did that one. Did you do this one?
no, we did one at 2
We
cubed.
didn't do the one over here. That's when we
Okay, I gave you this one? Okay, so this is a good one. It has 3 roots. You have to find one. Then you get down to a square. So find one of the roots, come down, you get down to here, and this is not factorable. So you can either complete the square, you can complete the square on this one nicely, or you can use the quadratic to get to here. These are conjugates. And again, check them in your calculator. Put it in your Y1, do a calc bell, and check one of these. You only need to check one. And you have to check the exact value. You can't check the decimal because it won't come out to be exactly 0. So at the end, whatever the highest exponent is, that's how many roots you should have found. Good. All right, let's try this next one. I think they get this one right. All right, so let's have you write this one down. Oh, I don't want to show you up here. Just write this one down. We're going to work this one out together. Because this has 5 roots. X to the 5th minus 7x to the 4th plus 10x cubed plus 14x squared minus 24x. Start like that. And I'm gonna okay, try it, guys. At least put it in your calculator right now, graph it. And then we'll go through this together. What's the first thing I can do in terms of factoring? Take out an x. So let's take out an x first. We're going to set this to 0, so let's take out an x first. Make life easy. So what is one of my zeros already? 0. But when you graph this, can you find me any more zeros? How many I'm down to a 4th. How many do I need to find in my calculator? 2. Now sometimes if you're looking for 3 and you only find 2, that means one of them must have been a double. So look at your graph as well to see if one of those was a double. Because when you're looking for some of these, you tend to say, well, I only found 2, I'm supposed to find 3. Go back, that's why I say go back and look at the graph. See what your sketch looks like. Can you find me 2 others? 3 and 4. So now, you only have to divide this one, by 3 and by 4. So let's pull out your coefficients. So 4, 3, 2, 1, 0. Which one would you like to divide by? 3. Yeah, I'm only going to use this one though. I'm not using this one because we factored out the x. You can use that one, and if you did, Anne-Marie, you'd put the 0 there. But the first thing you have to do is divide by 0, 3, or 4. Then you have to divide by 3 of them. And that's possible. That's fine too. So bring this down. Always bring this down and start. 1 times 3. What do I get when I come down? -4. I multiply from the left to the right. -12. Add down. Left to the right. -6. Add down. left to right. If this doesn't come out to be a 0, I did something wrong. Okay. Is synthetic division getting a little bit easier? I think what happens too is in Algebra 2 you are introduced to so many different procedures that you say, oh, this is so overwhelming. And sometimes you don't get to see why do we do all this. So, right, and you wouldn't have. You wouldn't have. I mean, we even do some things in pre-calc that I say like you're going to do this differently in calculus next year. So, or like the difference quotient. Right now you don't see why we use it, but you will at the end of the year, and you will use it next year. So sometimes you're learning like background things, but you don't really get to see why we use them yet. And I'm always a person of, okay, show me what I need to do with it now. You know, why do I need to do this? What do I need to do with it? So a lot of kids when they take math, it's confusing because you learn so many different things, and you say, and I love teaching Algebra 2 when I taught Algebra 2, but nothing fits together until you get pre-calc. So now we're going to do 4. So 1 times 4, just multiply left, bring it to the right. And again, if this didn't turn out, if this didn't turn out to be a 0, we're in trouble. So how many x's did I technically take away? I took these 2, and which one? 0, one more. So if I went from 5 to 4 to 3 to 2, this is x squared. So x squared plus 0x minus 2 equals 0. This guy is my last factor. So I set this equal to 0, and I say x squared equals 2. Take the square root. Don't forget your plus or minus. So I technically have 5 roots. And if I string them all out together, I don't care what order you put them in, because if you want to leave the plus or minus 2 together, that's absolutely fine with me. As long as you give me 5 at the end. Now, sometimes what happens is we get one more root. We can technically do this thing again. So say if I was able to do this again, and the last thing I came out to was this. This is my last factor. So when I look at this, this is my last root. Sometimes you can keep dividing all the way through. Just because we're finding 3, it doesn't mean if we found 4, we can't divide by 4 to get the 5th one. I mean, this one we couldn't, but in the case of sometimes you can divide again and get to this last one when x is 1, this is your last factor. And you can do it that way. Okay? All right, there's one I want to show you from yesterday that we missed. And we're going to do this 2 different ways. One, the way you're going to moan about, so we're going to do it anyway. And one, the way we'll do together, normally. I mean, I'll let you do it that way at any other time. Okay. All right, ready? Now, you're given one real 0. So what did you do with that 0? We divide by that 0. So we're going to do the same thing. Sometimes we say x is 2, x is 0, x is 1, x is 6, and we divide by that number. So we're going to do the same thing. We're going to pull this out, and we're going to divide by this 0.
We have it.
No. This is the one I forgot to give you. Sorry. You can put it on somewhere. Now, do the same thing. Doesn't matter how bad it looks. It's going to look a little bad in the beginning, but it'll get a little bit better. I need to find how many zeros here. 3. They gave me 1. But, do I know another one? Probably plus, because why? They go together because they're called conjugates. Good. So I technically do know 2. So if I divide by one, God bless you, and I divide by the other, I should get my very last root. So we're going to see how that works. Pull out your coefficients. What do we got? 1, negative 1. Leave yourself a little space here. So 3, 2, 1, 0. We do this the same exact way we did before. We bring down the 1, and we multiply. What is 1 times 2 minus radical 5? Okay, and then what did we do? We added down, right? So if we add down, we add negative 1 plus 2, what do we get? 1 minus radical 5. This stays together. It's not pretty. So now we have to multiply again, don't we? And move to the right. So we have to multiply 2 minus radical 5 times 1 minus radical 5. So this gives us 2 minus 2 radical 5 minus 1 radical 5. And what's the last thing we get? Plus 5. So we combine our like terms, and we get 7 minus 3. Right? Did we get 7 minus 3 radical 5? Okay, don't panic. Don't panic. So we get 7 minus 3 radical 5. We do the same thing, we add down. So I can only add my real components here. So what is negative 13 plus 7? Negative 6 minus 3 radical 5. Really bad looking. Really bad looking. But remember, what's that last thing going to come down to? A 0. So now I have to multiply 2 minus radical 5 times negative 6 minus 3 radical 5. So I get negative 12. I get negative 6 radical 5. I get a negative times a negative gives me a positive 6 radical 5. And the last thing I do is a negative times a negative. I get a positive 3 times 5, which is what? 15. So these are canceled out. And what is a negative 12 plus 15? 3. Ah, look at how nice that was. And that's a 0. But that has to come out to be 0. If it doesn't, I say, oh, this mess gets worse as it goes because I did something wrong. So now I'm stuck. If I didn't know what Lily told me, I would be stuck. This is an x squared thing. I never saw anything like this with an x squared. So Lily already told me that I get another root out of this because they're conjugates. So I divide again by 2 plus radical 5. God bless you. I'm sorry? Because these are conjugate pairs. They came from your quadratic or from complete the square. So if I get one, I know the other. If I was here and I say, oh, I have to find 2 more, how am I going to find 2 more out of this mess? Not possible, right? But I know those are conjugate pairs. So I divide by this one. This is the easy part. I bring down the 1. I multiply this. 2 plus radical 5. Add it down. What do you get? The radical 5s come out. You get 3. 3 times this is what? 6 plus 3 radical 5. Oh, when I add this down, don't I get a 0? That was the easy one, right? So now, I took 2 away. So what's this x going to start with? X, just x to the 1 or x? X plus 3. This is my last factor, not x equals 3, x plus 3. Then I set this equal to 0, and I find my last root. So I have 3 roots. To use my conjugate pair. Not bad, right? Okay, alternate method. Everybody okay with this so far? You can absolutely do this. When you learn the alternate method, it's just a lot easier. Okay? Ready? what would you think?
That's a good question.
Put it in your calculator, somehow it is.
Well, yeah, but you wouldn't solve it algebraically. Now, I want you to think back for like a couple of lessons ago. When I gave you the roots and I told you to come up with the equation.
Oh, you did that. You put it into the first place.
You plug it into that, the sum and the product. You were very, very close. Sum and the product. So the sum is negative b over a, and the product is c over a. Now do these in your calculator. Do this and take the sum of these two roots. What do I get? I'm taking the sum and the product. We're getting down to a quadratic. So what's the sum? Of these two, because we know we have two, of these two zeros. We're going to get to that. We have to take the sum of this first.
Oh, yeah, and then the A plus the
And then we get rid of the a. So take the sum of this. What is the sum?
4.
Do it in your calculator. 4. The radicals go away. So now, we say let a equal 1. Therefore, what's b equal to? Negative b is equal to 4. What's b equal to? Negative 4. Now, in your calculator, pull it down and change it to a multiply. What's the product equal to? Negative 1. So we know A, so now what is C? C is negative 1. So I'm dividing this whole thing by that quadratic. Because isn't that quadratic give me those two zeros? So now what? X squared minus 4x minus 1. I'm dividing it by this.
Wait, what is it for C and A?
We took the sum, these are your two formulas. So we took the sum of these two roots, these conjugate pairs. We took the sum, and then we found the sum to be 4 because the radicals go away. I set it equal to negative b over a. So since we had one equation with two variables, we let a equal 1. Therefore, b is negative b is 4, so b is negative 4. We did the same thing with the product. The product of those two came out to be negative 1. We already got rid of a, so therefore c is negative 1. We did this last maybe Monday, last week sometime. Okay, so now, can I divide this? If I divide this, won't I get my last one? I got a 3 over 2. Won't I get an x equals something? I'll get my last factor. So let's divide this. So I have a 1, minus 1, minus 13, minus 3. My leading coefficient is a 1, so I'm okay there. I got a double divide, because don't I have two roots in there? So does the double divide kind of make a little bit more sense? I have two roots in there. Oh, this is so much easier.
This is the morning one. It's another one. It's like the screening one.
That's because last year you guys didn't do these so good. So you did summer product, and these worked out really, really well. Okay, hang in there with me for 1 minute. So let's divide this out. We said this comes out the opposite way. Hang on for 1 minute. This is good practice. So bring down the 1. This is a double multiply. You're multiplying from left, going to the right. 4 times 1, go to the right. 4. 1 times 1, go to the right. 1. Add this down. What do you get? Negative 1 and 4. 3. 4 times 3, go to the right. 12. 1 times 3, go to the right. 3. Stop and add down. 0 and 0. Which makes sense, right?
Wow.
So x cubed over x squared gives us x. Here's my last factor. That's my last factor. Set this equal to 0, and x is negative 3.
That's cool.
You like the other way?
Yeah.
Oh my goodness, I love this way better. You guys are just not comfortable with your sum and product.
No, because I don't get why the A. I just don't get why. I don't know why you divide this by something.
Okay, okay, let's stop a second. Guys, I need it quiet in here. What if I gave you this? It's not the same thing. What if I gave you this? This is your problem. What would you do?
No. Put the 3 out, the negative 3 outside that in the synthetic.
You would divide by a negative 3, right? I gave you one root. I gave you one factor, so I'm giving you basically one root. I'm saying divide this by the 0. What is that 0? Negative 3. So you divide this whole thing by a negative 3. And you're going to get a quadratic that looks just like this.
Then you get like a negative 1/3 x.
You get this, watch. 1 minus 1 minus 13 minus 3. Okay, stay with me for a second. Bring this down. This gives you negative 3. This gives you negative 4. This gives you positive 12. This gives you negative 1. This gives you a 3. X squared minus 4x minus 1. Isn't that what we were left with? And what would you do when you got down to there? You would try to factor it, or you use quadratic, because you can't factor it, right? So didn't we just walk everything backwards? Which is exactly backwards that we did. Now you had to do your quadratic. So instead, this was your quadratic answer. So we brought it back to what was that quadratic, and then we just divided it by that to find the last 0. Just walked it backwards.
Where'd you get the 4 and 1 from?
This, sum and product.
Like I could do it that way, like the zeros that they gave us were like regular numbers.
We're giving you nice ones, but they don't always come out
Yeah,
nice, right?
that's what I'm saying.
Your answers don't always come out nice.
I get it, I just don't get why A is 1.
Okay, so let's do, for me to find one I have to do, hang on. This will take me a minute.
I got the negative B part. I just don't get why, like, when you divide it by A, it just cancels that out.
I'm never going to be able to find a problem in here to do. Okay. Let's step back a second. I have to take this out. Guys, I need the talking to stop. I think that's part of the problem. There's a lot of talking going on. Okay. Way back, when we found your equations, let's go back to pre-calc. We're in pre-calc. Let's go back to find a polynomial. This was classwork 2. We said we had a polynomial with the following zeros, and we had to come out up with the polynomial. And we started out with a real simple one. We said, what happens when I have x equals 3, x equals 2? We work these backwards. And there was our polynomial. There was our polynomial, our quadratic in this case. So we were kind of stuck with these. But we said this was doable. X equals 0, x equals 2. So you found your factors. Here's the difference. These are zeros. These are factors. Okay? And how did we get that? We did the sum and the product. So sum is negative b over a. Product is c over a. These are two formulas. So the a and the b correspond to these. That will get us back to a quadratic. Quadratic that wasn't factorable. So we say, okay, take the sum of these guys. When you take the sum, put it in your calc. Don't the radicals go away? So what is the sum? 8. Now we're stuck. We have one equation with two variables. We can't solve one equation with two variables. So we say, okay, get rid of the a. Let a equal 1.
You just have to decide that.
We'll get back to that. I'll show you that in a second. So now, 8 is equal to negative b. Therefore, b is equal to negative 8. My product says multiply these. These are perfect squares. Let your calculator do it. You multiply the first, you multiply the last. So my product is 11. Well, we already let a equal 1, so therefore c is 11. So we plug these in. A is 1, b is negative 8, c is 11. Now, question comes about, you let a equal 1. Can you do that all the time? Yeah. What happens sometimes is this. A is not always 1 on all your quadratics, right? But what happens is this. If I let a equal 1, sometimes b will come out to be a fraction. And c will come out to be a fraction. So then when I put it in, a is 1, b is my fraction, c is my fraction. Do we really see your quadratic written like this? No. So they say what? Find a common denominator. 4. Multiply it by 4. There it is. So a is not 1 in this case. But we're just going to let a equal 1 just so we can get through that. If we come out with a fraction, we're just going to take a common denominator and get rid of that. And then a is not 1. You're right. It's not 1. But for us to start, we need a starting place. So we're going to say let a equal 1. There will be. There will be. There will be. You do your product and your sum. It has to work out. Okay, so what I want you to do today